I'm Guiller Olario, the game designer for our group project. Today I'll be presenting our game Academic Arena. My role is to design the game's mechanics, layout, and overall player experience, ensuring it's both strategic and engaging. In this presentation, I'll walk you through the core concept, classroom system, leader, roles, event cards in the game's objectives and strategy. Core game concept. In the academic arena, each player chooses a leader and deploys his student cards into different categories. Each student contributes knowledge points depending on their placement, making placement critical to success. The game encourages players to plan carefully, think ahead, and adapt their strategy based on both their own cards and their opponent's moves. So for the classroom row system, the classroom is divided into 3 seating rows: front, middle, and back row. The front row features high-impact students with strong influence on knowledge points. The middle row contains balanced students offering a mix of support and strategy. The back row provides utility and defensive support, enabling long-term planning. Proper placement in each row can greatly affect the outcome of the game. The leader system. Each player selects one leader at the start of the game. Leader provides unique passive abilities that influence gameplay. For example, the mentor strengthens students, particularly in the front row, while the strategist focuses on card advantage by allowing extra cards draws. This leader encourages different placement, making each match feel unique and strategic. The event cards. Event cards introduce unpredictability into the game. Example include the brainstorm session, which grants additional knowledge points to the row, and the surprise test, which imposes a penalty on a selected row. These cards require players to adapt their strategies, creating dynamic, engaging, and game experience. Objective and strategy overview. Each match is played over 2 rounds. Player must decide whether to use their cards early or save them for the next round. The player with the highest total knowledge points at the end of the 2 rounds wins. Academic Arena rewards careful planning, patient, and smart decision making.
Good day, sir. I'm responsible for the UI and UX design of Academic Arena. For the 20% game development, we focus on the basic layout and structure of the game rather than full visuals and animations. The main screen shows the player area and the AI opponent area where cards are placed. At this stage, the card placements are still uniform and not yet divided into front, middle, and back rows. This will be implemented in the next phase. At the start of each round, the player is given 10 cards. The player is allowed to redraw up to 3 cards only, which is controlled using the redraw button. The interface also includes an end turn button, which allows the player to finish their move and pass the turn to the AI. The user flow is simple. First, the round starts. Second, the player draws 10 cards. Third, the player may redraw cards up to 3 times. Fourth, the player places cards. And lastly, the player ends their turn. For now, the design focuses on clarity and functionality to make sure the game mechanics work before adding design visuals.
In this portion of the video, I will show the 20% output of our game. The first function we have created is to control the card by pressing the left mouse button. Now here in the input manager script, it is responsible for detecting mouse movement and figuring out what function the player will the game. Now the first thing we have created is function called input that checks both conditions, which are the first one is give us access to the 2D physics world. Now for the parameter, this creates a query object which works like a submitting a form to the space state. Now here in the parameter, not get position, we're accessing the position of the parameter and assigning it to the global position. Next here we are calling the variable parameter and accessing the property of collide area 2D, meaning we're telling Godot to include area 2D node when checking for collision. Here we have created a variable called result and calling the variable space state. Now we are calling this method called intercept point to ask the 2D physics world about parameter. Now here, if there are mouse collided with an area 2D, it will return an array. Now in this if statement, we're checking if the result size is greater than 0, meaning if our mouse has come in contact with the area 2D, it will print an array, meaning this condition will turn true. Now in this variable, we have created called result condition as we are getting the pass of the area 2D, which is set to number 1. Now in this nested if statement, if our collision pass, which is set to none, is equal to collision pass, which is also set to none, then we are getting the parent node of the area 2D, meaning this is cards in from our game. Now if we found the cards in this condition will turn true, we will call this card recognition, which has the script called card manager and calling this function and passing the card that we have found in the card manager. Now in the start card function, we have assigned the card that we have found to card being dragged, which is a variable in card manager script, so that we can access it through here. Now in here we are changing the card that we have found scale to default size of 0.6. Now since card being dragged has no access to the card that we have found, we are now checking it in the process function. Now once we have the card being dragged has a card, this condition will turn true and we created a mouse position that tracks my mouse position. In this part we have updated the card position to follow the mouse. Now a vector 2 is required because the position needs both x and y coordinate. We take the x and y values and pass it into the clump. Now the clump function limits the value between the minimum, which is set to 0, and maximum, which is the screen size, that x. Same with the y position, we have clumped the mouse position to the axis with the minimum 0 and the limited screen size of y. So the next function we have created is the ability to place the card in the card slot. In order to move the card and place it in the card slot, in our input function does listen for the left mouse button and is being pressed. It is emitting a signal called left mouse button is Bluetooth that we are connecting in our card manager script. Here we have connected the signal of left mouse button and calling this function on left click released, which checks a condition if our card is being dragged, then it executes this function called end card. Now in our end function, here we are changing the scale of the card to card zoom scale, which is set to 0.65. Next we created a variable called card slot.found, which is calling this function called raycast at slot cursor, which is this function that functions the same as our previous raycast with the variable of space state parameter, the global position, and collide with area 2D. The difference is this raycast function is checking if our mouse cursor is colliding with an area that has a containing layer mask 2, which is our card slot, and if the our mouse collides with the area 2D that contains layer mask 2, it will return it and give it to the card slot found variable. In the if statement, if our card slot variable gets the card slot seen, this condition will return true, and in the second condition, if card slot not card in slot, which is a variable in card slot script, which is set to false, and thanks to the not operator, this condition will turn true, so both conditions will now run and execute the code inside. The player hand reference, we're calling the variable player hand reference, which contains the player hand script. Then calling the function remove card from hand and passing in the card that we're being dragged. So the remove card from our hand function behaves like if our card is in the player hand will erase that card and update its position. Now the update position function automatically arrange the cards in the center of our hand depending on the length. Now in this line, we are taking the card being dragged variable and changing its position equals to the card slot that we have found position, meaning if we place the card in a card slot, its position will change based on the card slot that we have found. Now in this line, card being dragged, we're getting the node of the card that being dragged, area 2D in collision, and disabling it to true. Meaning once the card is placed in the card slot, we cannot change its position or move it. Next is we change the card slot that found card insert variable and set it to true. Else if the card slot was not found, we're calling the player hand reference and calling the add function. Add card to hand and passing the card being dragged, which the function of add card to hand is if the card is not in the player's hand, it will return back the card that was being dragged and update its position. The next function that we have created is the deck function that allows us to draw a card and add it to the player's hand. In order to draw a card in the game, in the input manager script, recast function in else if statement, we are checking if our mouse has collided with a collision mass of equals to 4, which is what our collision mass variable is setting. Now if the condition is true, we are calling the deck reference and calling the draw card function. Now the draw card function, we have here a variable called draw card that draws the first index in the array. Now we are calling the array player deck erase and removing that first card that we draw in the array. Now if the player deck size is equal to 0, area 2D in collision shape will be disabled, meaning our deck will not be interactable and the sprite 2D will be set to invisible. Same with our rich text label, we'll set it to false as well. Now in this line, we are updating the rich text label to show how many cards left are in the deck. Now in the variable card scene, this line loads the card scene into the memory. It makes sure that the card is displayed to be used immediately when you need to create a new card. Without the new card variable, this creates an instance of the card scene. Now in this line, this adds a new card to the card manager mode by adding this the card became part of the scene, meaning it will now appear in the game and be processed. In this line, it sets the name of the newly created card into card, which is this string. Now in this line, this sends a new card to the player hand script. The add card to the hand function responsible for positioning and organizing the card inside the player's hand. The next function we have created is to change the scale of the card when we hover over. In order to do that, we first connected a signal to the area 2D called mouse entered and mouse exit, which are these functions. Next, we have created a signal called hovered and hovered off. Now in this function, we are emitting a signal and calling the signal function called hovered and emitting itself, meaning the card. Once it successfully emitted itself, we are calling it in the card manager and connecting it. As you can see here, we are calling the signal hovered and immediately executing this function called on hovered over card. Now on the on hovered over card function, we are checking if hover over card is true or false. Since hover over card is a empty variable, it will return false. But thanks to the not operator, it will return true. And executing these lines of code. Here, hover over card is assigned to a true value and calling the function highlight card, passing the card that we are on top on and passing it to true value. Here in the highlight card, we're checking calling this function called hovered over card. Now in this function, we are checking if we are dragging a card. Since we're not dragging a card, the variable card being dragged will be empty and it will return false. And thanks to the not operator, it will turn true. And call this function called highlight card and passing in the card value and a false value, which immediately execute this else condition, which is changing the scale to default scale, which is 0.6 and changing its Z index to 2. Now in the off hover card, we have a variable called new card over hovered, which calls this raycast check for card function, which is right here. Now what this do is it checks for the world at mouse position to see if we are touching any card. If multiple cards are detected, it returns the one with the highest index, which is in this line. Now in this function, its primary purpose is to look through all the cards being detected and select the card that is visually on top and compare their Z index, which is in this line, and returns the highest index card.
Good day, sir. I am the project manager and documenter of the group. Our team is composed of 4 members, each with a specific role: game designer, UI/UX designer, programmer, and project manager, documenter. For the 20% game development, our goal was to complete the basic mechanics, layout, and gameplay flow of Academic Arena. We divided the tasks accordingly, monitored process, and ensured that the game follows the approved concept and requirements. Our next step include improving the card placement system, implementing leader abilities, refining the AI behaviors, and enhancing the user interface. This concludes our presentation of the 20% game development for Academic Arena. Thank you.